Okay, let's carry on. I'm going to demonstrate number 2 here, and after that we're gonna go straight to our quiz 01, okay? So on exercise number 2, text math, let's go back to Visual Studio. I'm gonna close this one, and I'm gonna ask for a new project, okay? Here, once you have created your first console app, you should be able to see recent project templates, and you should see right away consoleapp.net framework there. So select that one. The name, I'll call this text math, but as I have a few already, I'm gonna say this 04. I'm gonna create, and here we have include 2 overloaded methods, one that accepts price and tax rates expressed as doubles, and another one that accepts price as double and tax rate as integer. Okay, so let's do that. Let's call static. I'm gonna go straight to the type here. So I want the tax value. So tax value, I should most likely be using which data type? A double. So let's use a double here. Let's return a double, and let's call this calculate tax. And you're going to have 2 arguments, a double price, and the first one is a double as well. Yes, 0.06. So double. I'm going to call it tax rate, just so we practice the uppercase, lowercase. Then you're going to close this. And the math is quite simple here. I'm going to say double output. I'm going to just declare a simple variable here, which will take the price. And in the first one, what we're going to do? We're going to just do what with tax rate here? So tax rate will come as 0.06. So to calculate the tax rate, I just have to do what between tax rate and price? I just want the tax. I don't want the total value, okay? So I just need to do what?
Tax rate divided by price multiplied by 100.
Tax rate, let's say if I want to say 6%, it will come in as 0.06. So again, what is the math here that I have to put together? Okay, tax rate 0.06, price, let's say 80. How do I get the tax?
Are we doing as a hard-coded value from the user, or just if the user put 0.00007?
0.07 is 6%. So if it receives 0.06, price time? Times tax rate. Okay, so that's what I'm looking for. And then I'm going to return this output. So that's the first version. The second version, I'm going to copy this just to use as a starting point. But instead of tax rate being a double, tax rate will be an integer. So the second time here, I'm going to send a 6. If I want 6%, I'm going to send 6. So I have to do what here? Divide by 100. Okay, now here's the thing. If I leave it like this, actually, I'll show that in a second. So the math is correct here. Now I just need to output this. So as I usually like to do, I like to keep the methods very clean and leave the output to the main methods. Just my way. If you are doing the output to the console right from here, that's fine as well. I just want to make sure that you overloaded this properly. So here I'm going to say double. I'm going to say tax value 01 equals to calculate tax. Actually, let me read the last part here. So again, okay, there are no default values. Okay, it's just like that. Okay, so let's just do this. Calculate tax. let's see the price 79.95, okay, so 79.95, and then the first one we're going to send a 0.06. So for this one, it will fit the first one. We're going to do the same thing for the second one. Let's talk about that in a second. Let's see how that goes. I'll cover that in a second. Now, here. Okay, so let's output this. I'm going to say console.writeLine, and I'm going to say text 1, and I'm going to use a string interpolation here. I'm going to say, and if I want to format this as a dollar format, I can just say C or lowercase c. I don't think that there is a difference, but there might be a difference, but I just don't know what it is right now. And then text 2, we're going to say text value 02, and let's give it a try. Let's say Control F5. Okay, not that one. Okay, Control F5. And there we have. So we are just taking the text value, okay? Now, to your point about the 100s, we didn't have a problem here. You know why? Because the multiplication is happening before. Now, if by any chance you did something like this, then you're going to have a little problem here. Let's see what will happen. Look at that. We're getting 0 there. Who can explain me the reason why?
Because when tax rate will be divided by 100, we'll take it as 0 because that's an integer value.
Yeah, and so when we divide an integer by another integer, you're going to get an integer, okay? But if we are sending 6 here divided by 100, and we just get the rounded number, we're going to get a rounded 0. 0 times price, we're going to get 0. So, again, if you have done this, different ways to solve this. You can get rid of the parentheses, that's one. But you can also do something like this. Because then 100 becomes, 100 which used to be integer, becomes a double here. So if we divide an integer by a double, the result is a double. So this case, it would work. See? Awesome. Okay, questions? Anything? Any questions? Okay, okay, so I'm just checking here. Padlets. All seems calm. That's good. Okay, so this will be uploaded by Monday the latest. How about we go to our quiz, quiz 01. You're going to have 10 minutes to do that, 4 questions. They are very simple. You're going to see that you're going to get them done in 5 minutes, actually. But you have 10. I'm just going to set it up. So give me 1 second here. You're going to be able to see that. By the way, I think that some of you, and I didn't have a chance to answer yet, some of you are telling me that you cannot see bonus 1. Most likely that's because you have changed sections, and when I gave permission, you are not there yet. So I'll get back to you via email. If this is your first class, I will open up bonus 1 so you can still submit by next week as well, if this is your first class, and you won't miss your bonus 1. Okay? So I'll get back to you on that. Okay, so you should see quiz. Not yet, I didn't set it up yet, but under assessments, quizzes, please go there. You won't see it yet, but I'm in the process of setting it up right now.
So this is going to be coding or?
Just multiple choice. Just a quiz, a multiple choice quiz. 4 questions and that's it. Okay, can you please confirm? You should be able to refresh your quizzes there and should be able to see quiz 1, 01. If you can see it, just move forward. No, cannot see it yet. Anyone? You cannot see it? You see it? Anybody else? You cannot see it? You see? Who cannot see it? Just you? Can you refresh? Are you under assessments, quizzes? Anyway, for the rest of you that can see it, move forward. Can you see now? Yep. So get started. You have 10 minutes to get it done. You cannot? Can you click there? Can you click quiz 1? That's it. Start quiz. Okay.
it exactly as you did. The coding still is showing error.
Okay, so let's see here. Move the mouse over.
Here,
Yep, let's see. This call is ambiguous. Well, not exactly. Tax rate here is int.
sorry.
Tax rate
It's
here is int.
Yeah.
Okay? Okay, so hope that you did well. See, it's easy, isn't it? Tell me. Confusing? Okay, at least that. I mean, cannot be 100% easy. It has to be a little bit hard. Anyway, let's move on to yet another topic here. The rest of our class today, we're going to be talking about this. So it will be mostly talking. There will be some quizzes, some exercise, but quiz, I mean just not non-graded quiz. Enough of graded quiz, so only ungraded ones. A few exercises like that, but no hands-on anymore for today. We're going to go hands-on for this topic here next week, okay? So, classes and objects. Today, who can tell me
Container, classes
classes are
are container.
containers? Is that what you're saying? Yeah. Let's see. I want to hear from you what we understand about classes and objects. Can anyone give me some explanation of what are they? Maybe not even from a technical standpoint. Maybe draw a parallel of classes and objects with real life.
Similar things in the same class, like which have similar attributes. So, like we all are students, so we are in the class.
Okay. Go ahead, Michael.
Like a class is like a form that you have to fill out. So there's empty slots there.
Yep.
And then from that you can make copies of it, different objects.
Okay. Okay. Copies. Yep.
And fill them all out differently.
I like that. Copies. Yep.
Class is like a blueprint of a idea based on which we can create multiple classes, and like it's like creating a house, like a blueprint of a house. We can create multiple houses and put multiple objects inside.
Okay. Got it. You had someone else here? You had a no? Nobody? Okay. I like that. Actually, that's usually the way I describe. A class is like a blueprint of a building, of a house. All your descriptions were fine as well. Again, there's not really right or wrong answer here. I'm just trying to draw parallels to the real world. So, a class is like a blueprint. It's the plan for a house. A blueprint is the plan for a house, for a building. You have the actual building, but you have the blueprint that is the plan for that building. So a class is like the plan for an object. It's not the object yet, it's not the thing yet. A blueprint is not the building, it's not the house. A blueprint is just a plan for the house. A class is just a plan for the employee. Will have its attributes, its behaviors, but it's not the employee yet. Okay? So, what we're going to be looking at today, we're going to be looking at how we're going to define a class, how we define classes, how we create objects from those classes, how we use properties. Properties, not so much today, but we're going to be talking about class members. We're going to be talking about private, public, internal. Those are accessibility modifiers, access modifiers that we can have for classes, we can have for methods, for properties, for fields. What we're going to be talking about today in this section, this segment, is chapter 9 of the book. Okay? Okay. Instead of reading that, I want to show you something. Let's say our last exercise, text math. As soon as we created our project, our console application, we have already one class there. What is the name of our class? Program. So by default, when we ask for a new console application, we create automatically, Visual should create for us automatically a class called program. Can we change this name? Yes, we can. To be honest, don't bother change that. We're going to be using the class program just to be the starting point of our applications, okay? Don't bother change that. If you, by any chance, if you change that, I would recommend that you change the file name together so you can keep things consistent, okay? Eventually, as we get more and more involved with classes, I'm going to ask you to create each class in a separate file just to keep things organized, tidy, okay? Great, so we have this class here. This is an application class. It's a special type of class because it has the main, to be quite honest, the main purpose of having this initial class is just to run the application, just to allow us to run the application. We usually don't do much else with this class other than being the starting point of our application, okay? And in in other words, this is what this is talking about. It's talking about application programs, the main. Also keep in mind, I think I mentioned that already, but you can only have one class in a project that has the main method. If you have two classes with main, the application, the compiler, will not know where it should start the application from. Is it the method main in this class or on that other class? So just one main method per project, okay? Let's have a look here. Look, we have another program here, but this time around, the program name has been changed to create employee. Again, as I said, you can change the program name. As long as you keep the main method, you can change the name, no problem. But now, we have something here. We have something new here that we have not seen before. We have, what is this? It's an object of which type? Of employee. So when we say this, employee, my assistant, what are we doing? Just with that part. We are not creating yet. We are just doing what? This part here. We are doing what here? We are just initializing. No, we're not initializing yet. We're just declaring. You're just declaring. Okay? So first we declare employee my assistant, and then what are we doing here? Initializing. Yes, no, I would rather use a different terminology. So we are creating an instance. We are calling the constructor. We are creating an instance. We are instantiating. Yeah, we are creating an instance. We are instantiating. So you declare and you instantiate. What this does, actually, what is this doing here? It's actually happening behind the scenes. Any memory doing what in memory? Yes, the new keyword is allocating memory, enough memory to store one employee, one object, okay? So the new keyword is doing that. When we are dealing with primitive types, and I'm adding string to that, even though string is not really a primitive type, but we call them variables. When we create an integer, when we declare an integer, double, a string, we are declaring variables. When we declare things that are a little bit more complex, like objects, we don't call them variables, we call them objects, okay? So it's just a terminology, from a terminology standpoint. You can still think of variable here, but again, variable, we usually refer to those primitive types, okay? So now we allocate memory, we call the constructor. Constructors we're gonna be talking about next class, not today, but it's part of this chapter as well.
Sorry.
Yes.
This employee bracket is not a method, it's a constructor.
Yes, yes, yes. There is a difference between a constructor and a method. So employee, parenthesis here, it's called a constructor, okay? And we're gonna see how to work with constructors a little bit, actually, right next class, okay? And then we call our object here, and what is this?
Method.
Is this a method, a field, a property? How do I know that this is a method? How do you know that this is a method? The way it's typed? What do you mean? Okay, got it. So that's, you're correct, but I could have a property, a method with wrongly capitalized. I could have that. It would still work. What it really gives me the clue that this is a method is the parenthesis. The parenthesis tells me that this is a method, not anything else. It's not a property, it's not a field, okay? Great. But when you look at that, if that's the only code that you see and you don't see anything else, what would be the question that you would ask? Where is the? Well, correct, but you can extrapolate that question. Where is what? Where is? Definition of the method. But even before we get to the methods, there is a bigger question. Where's the class? Which class? Employee. Where's the employee? Where's Wally? Where's employee? Okay? So we put together employee. Here's employee. We have the class employee. Great. Okay, a lot of concepts we're going to be talking about today in the next hour here, okay? So if you want to make some notes as you go along, that's fine. Next class, we're going to go hands-on. I don't believe in coding by watching, okay? I believe in coding by coding, okay? But again, we have to mix things in a little bit of lecturing theory, and then you go hands-on. So hands-on will be really next class. Anyway, we have our class employee. What is this? Private int ID number. What is that ID number? A variable. A variable, which is set to private. Let's hold on for a second. Private and public, let's keep that aside for a second. So a variable, ID number is a variable. Well, when it comes to object-oriented programming, when it comes to classes, for those variables, we have another terminology that we usually use. We call it something else. We don't call it them really variable. We call them, anyone? Members. Members, so that's a good one. Members, yes, but members is a general term for anything that belongs to a class. Not only this, but welcome message is a member as well. So which term do you use for this guy here? Fields. We're going to use fields. We're going to call that fields, okay? So fields are the elements that will store the data points of our class. If I'm dealing with a student, I'm going to have first name is one field, last name in other fields, username in other fields, and then it goes on and on like that. Okay? So we call this fields. So field is one type of member. It's a type of a member. Members, everything that belongs to a class are members. But we have different types of members. We're going to focus today on 3 different types. Fields are one. So we have a field here. Then what is this? We have a method. So methods inside objects are called methods. Okay? Just methods. No difference here. So we have a method, we have a field. One is set to private, another one is set to public. Private and public. How does that affect what we can and cannot do? When it's set to private, what is the restriction?
Class to within project, within one solution.
So let's talk about the scope. So where is this ID visible if it's private? Just within the class, okay? So only inside this class is this ID number visible, okay? But if it's set to public, it's visible inside and outside. That's why I can write that dot welcome message. If welcome message was set to private, we could not call that outside the class, okay? Now, there's something that I'll be saying, there's a phrase that I'm saying many times, not only today, but throughout the course, is that in object-oriented programming, we keep as a standard, as part of the best practice of object-oriented programming, we keep fields private and methods public in general. Can we have private methods? Yes, we can. If we have methods that are only relevant inside the class, make them private. But data is exposed outside of the class via public elements. But fields we keep them private. Data, we keep data private. We keep data under control. And I'll talk a little bit more about that, why, a little bit later, after we see, let's see. Yeah, but again, very important to understand this. Let's keep fields private. Fields, they store the data. We keep data private. Now, we're gonna, of course, let other classes see that data somehow, but we don't give them, and by them I mean the outside classes, we don't give them visibility directly into our data fields. We don't give that to them. And hopefully you're gonna get to know, that's part of object-oriented programming, and we use that as best practice. And I'm gonna give some examples here about that as well. A few definitions here. Let's see. So as we have said already, this is a field. By the way, this is one example, and this class employee is just an alternative to this employee here. I'm not implying that both codes will be in the same project, okay? This is just showing an example of fields, and which this one is a field. And then we have states here. What is a state? Again, just a term that can be found, that you may come across. I don't mention that name too often, but you may come across that in exercises. So state is what? The current what?
Value
the current value, the value of the variable or the field or the property here. Okay? In this case, yeah. So we mentioned about two types of members so far, a field and a method. But I also want to mention a third one, this one here. What type of member is this one? What name do we give to this one? It's a property. How do I know that this is a property? What tells me that this is a property? The get and sets. So a get and sets, you may have a read-only property that will only have gets. Okay? But if you have a get or a set, or both, it means that this is a property. A property is how we provide access to our data to the external world, to the external code outside of my class. We do that via properties. And we're not going to dive into properties right now, but that's how we do it. Okay? So, fields, methods, and properties, they are all members of classes, okay? Great. Let's do that matching. This matching exercise here is just about matching the keywords to the definition. If you want to take a screenshot of this matching thing here, I would suggest you to do that. Okay. Okay, can you open Nearpods? It will just take a minute to do this. Okay, so enter that code. On Nearpods, you're gonna see a matching exercise there. Let's do that. Okay, let's have a look together. Okay, so I'm going to read the definition, and you're going to tell me what is the match here. Are instantiations of a class objects. So you can call it instantiation, instances, examples. No. Are the actual value, the data, stored? For instance, the student name is John. John is what? John is the state of a property, of a variable, of a field. Are the blueprints for creating objects? We have classes. Are the data components of a class? The data components. So again, the data of the class is stored in the fields, okay? And then are the actions that perform operations. So we have methods here, okay? Great. Okay, let's have a look here. Okay, let's do this. Let's take 5 minutes to have our last break, and then we come back, we wrap things up. 5 minutes. Yep.
The code for the last exercise.
Show the code there?
Yeah, the code.
Yep.
The last one.
This one? Okay. Yep.
Is there any standards for naming convention for the solution?
For the solution name?
Yes, for the solution.
No, I mean,
Like
nothing,
you have to
nothing in particular, nothing in particular. No, that's okay. That you can,
give exercise one.
yeah. So here's the thing. Exercise 1 is project 1. Exercise 2 is project 2. Exercise 3 is project 3.
One solution we can create 2 projects.
3 up. You can even create more projects. Yeah.
So exercise name is exercise. Solution name is exercise 1, and project is like cinema and.
It could be.
math.
It could be. Yeah. Okay.
So do we need to paste the zip folder?
Do you need to?
Submit the zip folder.
The folder
Solution folder should be zip.
only for the assignments.
Yes.
Only for the assignment, but not exercises. Okay?
For the assignment, what we have to upload? Just the code.
The code, yes. You have to zip all the solution, so together with the projects, zip them up, upload all of that.
Geralmente ele repete Ctrl+V, Ctrl+V. É mais rápido. Que a gente não fazia, mas eu lembro que a Luana uma vez fez um dia ficou morrendo de raiva, morrendo, ele falou, mas não é isso? Ela morreu no Google. Tipo, do lado, né? Olhou, não, isso. O que aconteceu com o fundamento? Me ajuda na vista, né? Porque feedback, eu falo, tem que ser aquilo sem mudança, sem mudança. É claro, não isso, faz sem mudança, mas aí você aprende a aula, pelo menos está tudo errado. Não, ele dá aula disso. Não sei como. A pessoa que me mostra, a live não, mas é bom, acho que eu tenho, tá? Não deixa eu ter, ela é fixa.
Okay, so let's get moving here. Who knows how to put a breakpoint in the code? Breakpoints? Breakpoint experts? Debugging experts? Who else? Nobody else?
Just click on the like numbers where we want.
Okay,
to add
great.
the point.
Great, because here's the thing. I don't want any of you to leave this course without knowing that. I don't want you to get, to be my student there on web application development without knowing how to put up bloody breakpoints. And that happens all the time. We leave this course not knowing how to put a breakpoint in the codes. If you don't know that, how can you troubleshoot what's going wrong with your codes? You cannot. You have to guess. You have to keep staring at your code, and magically things will happen that it will click. Oh, that's the problem. No, I want to show you how to put breakpoints in your codes. Just want to demonstrate that. Now, we're going to be using that over time, and hopefully you're going to internalize that. But here, I'm just going to go to the exercise that we have, because I should have done that at that point, but I just remembered that, and then we're going to do it now. So here's that text application. Let's say that I want to put a breakpoint here on line 14, because I want to see what's going on with the variables at that point in time. So what I'm going to do is I'm going to move the mouse all the way to the gray area. Set this gray here, not here, okay? So we have this gray area inside the editor, and we click there. That's one way. What is the other way to put a breakpoint? I don't know the shortcut, to be quite honest. F what? F9? Let's see. F9 here. Look at that. I'm terrible at short. The only shortcut that I truly know is Ctrl+C, Ctrl+V. But Ctrl F9, now I know. The other way that I was looking for was you right-click the line, and then you go to breakpoints, and then you insert breakpoints. But I'm just going to keep the second one. So I'm going to run the application. One detail is that if you press Ctrl F5, sorry, not this one, Ctrl F5, it doesn't stop there, because it runs the application without debugging, okay? So you have to either just click Start or just press F5. So I'm going to click Start here. So it runs And when it gets to the point of that break point that you put, it stops there. And it shows this yellow line and this yellow arrow saying that the execution point is right here. Now, what you can do is you can examine, you can have a look at the value of the variables there. What's going on there? So we just have one variable here so far. Look, now I can see tax value 01. See, the value is 4.797. I can have a look what's going on. Okay? Now, the line that it stops before it runs the line. Okay? So right now, if I have a look at tax value 02, it's set to 0 because calculate tax didn't run yet. So for me to move to the next line and to keep debugging here, what should I press? What should I do here? Well, I can do F11. I can do F10. What is the difference between F11 and F10? F11, you go inside the method call. So if I press F11 now, it will go inside calculate tax, the second one. If I press F10, it will skip. It will go straight to the next line. I'm going to just press F10 here. So now I can move the mouse over and I can see the value of the second variable there. So that's how you troubleshoot. You can have as many breakpoints as you want, but that's how you put a breakpoint. That's how you troubleshoot. We're going to keep practicing this over time during this course. Because again, I want to see every one of you knowing how to troubleshoot your own code. Great. That was a bit of a side note, but I wanted to take the opportunity to mention that. Let's go back here to our main topic. A little bit more about terminology. This is yet another terminology that I don't use too much, but a class client is just a class that uses other classes. That's it. This class here called createEmployee, which is the application class, is using the class employee in one of its methods. So we call createEmployee as a class client because it's a client of employee. Employee is providing services to createEmployee, which we call a class client. It's a employee is serving createEmployee class. So we call this a client class, a class client. Again, just a little bit of terminology. Now, this is not, to be honest, super important, but this is important. Instance methods. This is important. Very important. What is instance again? Instance? It's an object, is it? Okay. Who knows what is an instance method?
Specific to every instance. It's unique to every instance.
Unique to every instance. Yeah, very good. Good. What does that mean? I mean, let's try to unpack that.
It will have unique values for all different objects.
So, can I say employee.welcome message? No, because employee is the class. And this method is not for the class to be used with the class. It's for the objects of that class to use them. It's subtle, a subtle difference, but there is a difference there. Let's unpack this a little bit further. Let's see here. Yeah, let me go back here to this one. So, welcome message. Actually, let's have a look at main. Can you see this keyword here, static? So static is present here, but it's not here on welcome, okay? Not here at all. So the keyword static is what makes the difference between an instance method and a class method. A class method does not change object by object, as you were mentioning there. But an instance method will be different for each object that calls that. Actually, not only that, but you cannot call a dynamic method or a non-static method from the class itself. You cannot. As well as you cannot call a static method from an object. Let me see how far we are from that topic here. Let's see. We are a bit far. Okay.
So we need to type the word static in the method?
I'm going to skip a few slides here and we can come back. I want to address this already. Let's talk a little bit about static and non-static with this example here. We have a class here called account. Account has how many members? Four members. It has two what? Two fields and two methods, okay? Look at this. We have two statics and two non-static. So the first one is static, the third one is static, and the second one is non-static, the last one is non-static. Let me try to explain what static and non-static, and as a consequence, what a method instance in an instance method in a class method, how they come about. Let's say that we have a bank. We're coding for a bank. And this bank has a general interest rate. So interest rate, let's say it's 9%. It doesn't matter if it's my account, if it's your account, if it's John's account. It doesn't matter, it's 9% for everybody. Yeah, maybe it's not the real. We can even think about, the interest rate of Bank of Canada. It's one, it doesn't matter which bank we are talking about. It doesn't matter which account we are talking about. It's a global information. So we can have the interest rates being static because, again, it does depend if it's your account or my account. It's global. So it does need to be tied up to specific objects. It's tied up to the general class, okay? That's what we see there. We see interest rate and we see get interest rate. They are both static. You don't need to create objects of the type account to get to them. However, let's look at the non-static ones. Which one is non-static there? Balance is non-static, and the other one? Get balance is non-static. But here's the thing. The balance of an account, it's specific for my account. For your account, you have another balance. For John's account has another balance. So it's not something global. It's something that will change per different accounts. Each account will have a different balance. Okay? So the way you get to the balance is by declaring one object of the type account. I'm going to go to the next slide here. So look at this. How do you get to the interest rate? Via the name of the class directly. You don't need an object of that class. You can call the class name dot class method, because this is a static method. However, to get the balance, you have to declare an object of that type account. You have to create it, instantiate it, and then you can reach get balance here. I get it if this is not super clear, but as we practice this, it will become more and more clear. But keep in mind that we have static and non-static methods, not just methods, but properties, fields, members in general. We have static members and non-static. Static, you're going to see the keyword static. Non-static, there's no keyword non-static. It's the absence of static.
Sorry, it means that, for example, account get interest rates, when it means, in this case, static, that doesn't change the value, or doesn't change?
It doesn't change per object. It's not variable per object. It's global to any object of that class. Now, here's the thing. Although it's global, but you cannot access get interest rates from client account. You cannot say client account dot get interest rates. You have to access from the class name. You cannot access from the object name. Okay? So whatever member is static, you can only reach them via the class name. Whatever member is dynamic or non-static, you can only access them via objects of that type. Okay?
But how you define this?
You define this as you create the class, you define them. How now? Let's say that
You need to know, like on the name, what it means, right? To declare if it's static or not.
yeah, you need to know the meaning. You don't do this blindly. You need to know the meaning of what you are putting together. Now, there is a way. Let's say that you get a class, and do you want to know which methods are static and which ones are dynamic? Very easy to do. You just put the class name dot. When you put the class name dot, whatever shows up, well, most likely it's static, because it's showing up right there. Visual Studio, the IntelliSense of Visual Studio will only show you things that are accessible at that point. So again, if you put account dot, you should be able to see get interest rate, but you should not be able to see get balance. Now,
If I type a client account,
now, if you type a client account dot, it should only show non-static methods, members, properties, but non-static ones. Because IntelliSense is already doing that work for you in a way. A lot of concepts, a lot of, but that's fine. That's how you get through the course, getting to learn new stuff. Any questions? Yes.
Can we change the static variable through a non-static method?
If we can change so if you can remove the keywords,
No, change the static variable
or if you can change the value,
through the non-static method.
we can. So if we have, now, here's the thing. Hopefully, we are not exposing a field. So fields, as I said, in general, should be private. Whether it's a static field or non-static field. But can you change the value? Yes, you can change the value. So static does mean that it's a constant. It's not a constant. Constants, you cannot change the value dynamically. Static data, you can change the values. It does mean that it does not change. What I'm saying is that it does not change per object, but globally you can change it. Okay? But again, just remember that whether it's static or not, non-static, fields should be kept private. Okay? We can have static fields, non-static fields, but they are both, look at this, private. Okay? So they are being accessible by the use of methods. Let's have a look at some of the things here. Will give you more insights into that. I'm just gonna step back here where we were before, and let's talk a little bit about access modifiers in the context of classes, okay? So when it comes to classes, we have 4 modifiers here, but 2 of them are only applicable if we are talking about classes inside classes, nested classes. So for now, I think that we are good enough with one single level of classes. Let's stick to that for now, at least for this class. So if we are just talking about one level of classes, let's forget about those two for a second, okay? Ignore this for a second. This is only applicable for classes inside classes, inside classes, inside classes, and enough of classes. So let's just have one level of classes here. For high-level classes, we just have two modifiers, internal and public. Let me get back here for a second. Look at this. We have the class employee here as well, but there's no modifier. Where's the public here? So if there's no modifier, it means that it is internal. So we have two options, either internal or public right now. Internal is more restricted than public. So if there's no access modifier in a class, the default is internal. It becomes internal. Okay? So what? What is internal and what is public? What is the difference? Come on, the coders out there, tell me what is the difference between internal and public for a class. Internal cannot be accessed. If we have a class that cannot be accessed,
We have to make it public.
okay, hold on. Yeah, it's about being able to access or not, but in which scenario? Again, internal and public. When should I use one or the other one? What is the use case? What is the use? Anyone? Okay, start again.
The scope of the package.
Yep. What is package? What is a package? Okay, projects. Got it? So projects. So say it again. Internal. If it's internal.
So if they're in the same project, they can probably use the methods inside.
Yep.
In a different project, they will be able to.
They will not or they will? No, not. Okay, great. So that's right. That's correct. So let's say that if we have two projects, project A, project B. I'm going to call them projects. They could be called assemblies, applications. We have two projects. If project A has a class called employee, and this class is set to internal, project B cannot see that, never. Even if, because here's the thing, with C# and other programming languages, one project can refer to the other project to be able to reuse things from the other projects, okay? From the other assemblies, you can call applications, DLLs, however, but let's think about in terms of projects. So we have a class called employee. Employee on project A is set to internal. So it cannot be visible by project B because it's set to internal. However, if it's set to public, it can be visible. That's about it. To be honest, nothing changes inside the same project. Whether it's internal or public, nothing will change if you are just using that class in one single project. It's only when you are using in the context of a separate project. Are you going to be using multiple projects in this class? Well, not today, but in the future when we're going to be doing tests, we're going to be using multiple projects at the same time, so this will be more relevant there. But keep that in mind. By default, classes are internal. If you want to make it visible externally, you make it public. That's about it. Yes?
Why not make everything public?
Why not? Yeah! Let's go crazy! Woohoo! Why not? Anyone? Not secure. Okay, I like that. I like the sound of that. Let's unpack that. Let's keep going. It's not secure. Why is it not secure? I'm the only one coding. I mean, am I hiding something from me? I mean, I'm the one coding here and coding the class there. I mean, again, let's think about that. Why not make everything public? Who has anything to hide, isn't it?
Like if one solution we have a different projects and we have the same class's name, then it can create problem if we created a public.
It would not really be a problem if they have the same names, because you can always precede the name of a class with the namespace. So again, I don't want to go there. It's not because of that. That's not really the main reason to avoid conflicts. It's about security. But again, why not make everything public? Why not?
It's good to practice now.
Okay, yes, I'm like that. It's going towards the right place. Again, we are working with object-oriented programming. There are a set of rules, standards with OOP. And one of those is to only expose whatever is required, whatever is necessary to be exposed. So things in general with object-oriented programming, by default, they are hidden. Why are we hiding things? Because we want to reduce, one of the reasons why, there are a few. We want to reduce complexity. Let me ask you this. And maybe it doesn't fit 100% to your point, but I'm going to give this example. How do you check that the gas in the tank of the car, what is the level? I mean, do you put your finger there and say, okay, so let me see here. You don't do that, but you could. So you have features in the car that will tell you, and you believe it. So the car is hiding a bunch of stuff from you. Because why should I care about the exact level of gas that because this thing is telling me here. What I care is being told right here. I don't care about every single detail of what my car is doing. I care about what's in my monitor there. So, do you believe that your car is way more complex than just what is being displayed there in the panel? It is, isn't it? But again, you don't see everything. So a lot of the complexities of a car, or for that point, a fridge, a microwave, a lot of the complexities are hidden from you. Because you don't need to care about those details. That's the same idea with object-oriented programming. What is that? Abstraction. So, yeah, it's the concept. It's called data hiding with object-oriented programming. But again, go ahead.
So it's not like a use public when something like input and output.
Well, input and output, yeah, you can use public for that. For those types of things, we have methods. I'm not saying that we hide everything. Because again, if we hide everything, then what's the point of having this thing doing something? It has to be able to receive an input and give some sort of output. I agree with that. But the point is that it doesn't have to be everything. It has to be selected things that you're going to be able to interact. And when I say you, I mean external classes that will call, will create, will instantiate objects of that class. So again, we don't expose everything because of that. Because have you heard this expression in a as-needed basis? Who has heard that expression before? I mean, you're gonna know about things in an as-needed basis. As needed. I mean, anyone? On a need-to-know basis. It's like you can apply that to object-oriented programming. We only expose things in a need-to-know basis. If it's required for some reason, we expose them. But there are also rules about how we're gonna expose things. And let me progress a little bit more.
When you show for other classes, you put public. So when you don't want to run something just fun.
Yep.
Calculation, keep it done.
Maybe because you want to reduce complexity. Maybe because you just don't want to give the other classes the option to mess around too much with your own class. Oh, you know what? This field here, I don't want to give them access. It should be only, it's only relevant inside the class. I don't want to give them the possibility to change this, because if they change this, maybe it will break the codes. Maybe it will do something that they're not supposed to do it, because they don't know what's going on. And when I say they, think of when you are coding in a team, you might be coding with people that are working the other side of the globe. You might be doing a piece of code that somebody else will be using your objects. You know your object better than they know. Okay, your class is what you have created there. Okay, so again, let me stop here, because otherwise it becomes just too much overcomplicated. Let's keep progressing, and as I see more opportunities to bring that up, I will keep bringing that up, okay? Because it's a very important concept, really. Okay, we spoke a little bit about this already. So again, if we don't see a modifier there, it means that it is internal, okay? Internal, for classes. Okay, let's see here. So static and static, we have seen this. Okay, great. So we're gonna wrap things up with this. Let's start with the video here.
Let's look at creating a class. Suppose you run a house-sitting business and you decide to create a house-sitting contract class. You might decide the fields that you need in the class are the client's name and the number of days that the contract extends. Suppose in another class you're writing a main method that declares a house-sitting contract object named con1. You might attempt to set con1 days field to 4. But when you try to send the 4 to the field, you can't get in because the data fields are private. They are not accessible by outside classes. Instead, what you might do is write a setDays method and make it public. The setDays method accepts a parameter, and if the number of days is greater than the maximum allowed, it forces days to maximum. Otherwise, it sets days to the number of days passed in. In the main method, you might say con1.setDays and pass in a value. The value can be passed into the method. It becomes num days within the method, and then it's assigned to days, which can get to the field. Because the setDays method and the field are in the same class, the days can be set by using the public method.
I'm going to pause there. I'm going to go back to the point. Who finds that this is very complicated? This is kind of messy, isn't it? Look, she's just trying to set the days as 4. That's it. How about we allow her just to do that? How about that? Can you agree that this would be way simpler? It's simpler, isn't it? For that to work, for this code, the way it is right now, what would we have to change to make that possible? We have to change this to be what? Public, isn't it? Just that, isn't it? So easy. Make it open. Everything is public. That's fine. But then what's the problem? There's a problem here if you do that. There's a conceptual problem. It's not a technical problem, but more conceptual. Is that, look at this. And you have to put in your heads that you might be coding this, but somebody else is coding this. Not necessarily you. If it's you, everything, you know better. You know that days can only be up to 7, not beyond 7. You know that. But let's say that it's not you. You're not the one doing this. So now you are exposing your days directly. And someone might even set your days to -10. Well, it's an integer. I can set any value there. I'm going to set to -10. Does that make sense? No, but you lost control of that once you made it public. Now you are giving direct access to your data to whoever wants to grab it. You lost the ability that you could have, you should have, to control how this data receives values. You are no longer in control of that. Because now, outside entities can access days directly and do whatever the hell they want. Okay? Does that make more sense? It's making, isn't it? Good. Does that make more sense? Is it? So that's why it becomes a little bit more complex, but we don't lose control of our data. We can impose our business rules. We can say, negative numbers, I don't accept negative numbers. I can even throw an exception. I can say, if someone puts a negative number, I'm going to explode. And by exploding, I mean, I'm going to throw an exception and let them handle that. They try to put the negative number here, their fault. I'm going to throw this back to them. So again, you can impose rules on your data. Again, I don't expect you all to be convinced about that. I'll be convincing you over time as we move forward, okay? But let's finish listening to Joyce.
Days field to 4. Instead, what you might do is write a setDays method and make it public. The setDays method accepts a parameter, and if the number of days is greater than the maximum allowed, it forces days to maximum. Otherwise, it sets days to the number of days passed in. In the main method, you might say con1.setDays and pass in a value. The value can be passed into the method. It becomes num days within the method, and then it's assigned to days, which can get to the field. Because the setDays method and the field are in the same class, the days can be set by using the public method. Similarly, in the main method, you might decide you want to output con1 days. But con1 days cannot get out. It's private. Instead, you have to write a public method, perhaps named getDays. It's public, so it's accessible by an outside class, and it returns the number of days. So back in the main method, you might write con1.getDays. And now, the days can be returned from the public method, and the program can use them. With most classes, you make your fields private. This concept is called data hiding. You control how you get to the fields through the use of public methods. Thanks for watching.
I'm just going to play the final seconds there again, because that's the key.
Be returned from the public method and the program. With most classes, you make your fields private. This concept is called data hiding. You control how you get to the fields through the use of public methods. Thanks for watching.
That's it. That's it. Not going to do the exercise. We're going to just stop it here. Any questions before I let you go? Any questions? Okay, so two things before that. One is bonus 2. Bonus 2 has been released under week 2. Okay? Bonus 2 is due by the beginning of next class, next week. So you have a week to have a look at that. Again, very similar to bonus 1. You have to listen to the podcast, and then you have to, let me quickly open that. So, content, week 2, bonus 2. So you have the episodes to listen to, answer that. Then you have a video, a 5-minute video, talking about UML. We're going to be talking about diagrams, class diagrams, okay? So have a look at this, ask me questions, You don't have questions? Okay, fake it. Just fake a question, okay? But ask me something, not the weather, but something related to this, okay? Okay, so that's one. Next one. Assignment 1 is due next Friday as well, okay? 11:30 p.m. What else? Also, if you want to get the exercises of this topic going, under week 2, I have this programming exercise 01. You can go there, you're gonna see 4 exercises. Most of the topics we have covered here, some of the topics that are required for those exercises, we will be talking about next week. But again, you know what you're doing, you're advanced, okay, go for it. Okay, if you want more, go to the end of the chapter, chapter 9. There are plenty of exercises there. That's about it. Questions? Okay, great. Be careful tomorrow, lots of snow. And have a good weekend. Great next week. I'll see you all next Friday. Thank you. Bye.
Can you open the link for bonus 1?
Yeah, so I'll also be opening bonus 1 link, just because some of you have transfer sections and things like that. So it will be open until next class as well, okay? Bonus 1. And then you can submit there, okay? That's it.